Assalamualaikum warahmatullahi wabarakatuh and good morning, Dato, Professor, ladies and gentlemen. It is a great pleasure for me to introduce our speaker today who is going to talk to us about the current technology, which is the fifth generation mobile network or 5G. This special talk will cover the features and benefit of 5G, where we as the consumers and the researchers are likely to know more on, I believe. Our speaker today, Professor Dr. Tharek Rahman, plays a leading role in establishing the first 5G initiative in Malaysia to foster collaboration and partnership between the academia and industry in 5G activities in Malaysia. Prof. Dr. Tharek also works closely with international 5G initiatives such as 5G Mobile Communication Promotion Forum from Japan and 5G Forum from Korea to promote knowledge transfer and collaboration in 5G research and development initiative and activities. Professor Dr. Tharek Abdurrahman was a professor in wireless communication at School of Electric Engineering, University Technology Malaysia, UTM. He obtained his bachelor degree honors in electrical engineering from University Strathclyde, UK, Master in Communication Engineering from UMIS, Manchester, United Kingdom, and PhD in Mobile Communication from University of Bristol, United Kingdom. Prof. Tharek conducted research related to mobile communication, antenna, and propagation. He has also conducted various short courses related to mobile and satellite communication to the telecommunications industry and government agencies since 1988. Prof. Dr. Tharek has published more than 300 scientific papers in journals and conferences and obtained many national and international awards. More than 30 PhD students had graduated under his supervision. He is an active member in several research academic entities and has been appointed as Fellow of Akademi Sains Malaysia. Dato, Professor, ladies and gentlemen, please join me to welcome Professor Dr. Tharek Abdurrahman. Silakan, Prof.
Okay, right. So thank you, Dr. Muzaffar. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to all the lecturers and also the postgraduate students. I understand that from Dr. Muzaffar that will be attending my talk today. So basically, let me share my slide first. Okay, Dr. Muzaffar, can you see my slide?
Yeah, I can see. Okay, now okay.
Okay, right. All right. So again, thanks for inviting me for this talk. So I think what I've tried to share today is related to the 5G technology, which means we are talking about what are the features and the benefit that we obtain. And I think for this, I will be covering four main topics plus a summary. First, I will be talking about the evolution of the mobile radio communication. So as you know that mobile communication started back in 1980s when we had the first generation. At that time, it's the analog system and it just for the voice application. Then you move further to the second generation, third, and so on. And then when we are reached to the stage where we have fourth generation and also the fifth generation. So I think I will also share here to cover what will be the capabilities. What is the difference? Now we know that 4G is been extended further the coverage throughout Malaysia under the Janela program. As we know that the target for the Janela program is to get at least 96.9% of the coverage in populated area with 35 megabit per second by end of this year. But I think the aspiration is that to get a 100% 4G coverage throughout the whole peninsula and Sabah and Sarawak. But again, I think now we are introducing 5G. So 5G will be what we try to understand now, while 5G is starting just a rollout by end of last year in Putrajaya, Cyberjaya, and also in Kuala Lumpur. And now it also been expanding to other states. And we will see now what is the difference between 4G and 5G. What are the advantage? What are the benefit that we obtain that we from that, and what are the features that is capable that 4G cannot do. So that one lead to the benefit that we are looking at, because we are looking into beyond broadband. I think beyond the connectivity of the broadband, we are talking about now from horizontal to verticals. The new industry come in. For example, you have this digital healthcare. You have this automotive. You have this manufacturing, and all those things can be benefited from the 5G technology when it's been introduced. And this led to the impact of the economy, to the country, where we're talking about open more opportunity. We are looking into not only for the what we call consumer, user, but also into the enterprise, the thing that it came up. And finally, talking about the summary of that. And also, maybe I'll be touching about the rollout of the 5G in Malaysia. What is the status, current status, and so on. Okay, first I'll be looking into the evolution of mobile radio communication. And as we see that this evolution of mobile communication started back in 1980s. At that time, we have what we call first generation, which is analog system. And for that time, we only capable of application is only for voice only. Okay, and I think what revolutionized mobile communication is the cellular concept, where you can apply frequency reuse and cell splitting. Then we can efficiently use the spectrum again and again in a given area. When that's why we say that first generation basically the foundation for mobile telephony and for voice only. When you move to the second generation in 1980s, that is where from analog to digital, not only voice that we can transmit, we can also send messages because since we have a digital there, at the time you remember still we have GPRS, H and so on. But the data rate still limited around 160 or 350 kilobit per second. And here we can say that it's enough capacity to provide the mobile telephony for everyone. Okay, then we move to the third generation, where the third generations happened in year 2000, and this is where we are talking about not only voice or the data messages, but we also talking about connecting to the internet. And this is where we have this 2 megabit at least. This is set the requirement. The standard of 3 is at least 2 megabit where you can access the internet. And then we can see that when we're talking about 3G, we can say that this is the foundation for mobile broadband. So we move further to the next generation in year 2010. This is 5G. 4G. 4G basically can support more efficient than the 3G, 3 to 4 times much better. That's why we can see that within the given resources, 4G can provide more capacity and more quality, as you can see here. And that's why we say that mobile broadband for everyone. For this is that happened in the 2010. And if we can see in the general program in our country, in Malaysia, that 3G sunset is happening end of last year, because the spectrum that used by 3G, if you can reuse it for 4G or upgrade it to the 4G, then we can have better efficiency, more efficient than utilizing the spectrum. That's why most of the technology now on 3G has been sunset, and then that resources been replaced with 4G. Then you can get better quality, to achieve that general expression. But 2G still maintained, because 4G will be supporting a voice over IP. They call it as a VoLTE. Where some phones, like feature phone you can see here, don't support the circuit switch or the VoLTE. They have to fall back to 2G. So for 2G was still there. And then we are talking about the data now all moves to the 4G and so on. Okay, so the next coming from 4G, the 2020 is 5G. So that's important to understand. What is 5G? What is the difference? And that's why we want to define. There are three different pillars. One thing is enhance further the mobile broadband that 4G can provide, improve further. And then the second thing is that we are talking about other new application is possible. We are talking about ultra reliable, low latency. It's the third pillar, second pillar here. meaning that they are very reliable and also low latency, much better than human response that it capable of doing other new things, other application beyond the broadband. And another third pillar that 5G can provide is the machine type communication, meaning that we can see that most of the sensors, things surrounding us are also connected to internet. Not only people connected to internet. There will be a massive connectivity there, which can support millions of devices per kilometer square. So next, if you see the in terms of the device, we can see, for example, and services. If you see that in the 1G, as I mentioned, it's now only for voice only. You move to 2G, you have voice and text. 3G, voice, text, and also can access internet, but at only 2 megabit. But when you come to 4G, this is where they enhance further, where through 4G, we have enough spectrum bandwidth, then the technology itself can support up to 1 gigabit. Meaning that if you are here, uh, you can access the internet at 1 gig. If you are traveling in fast train, for example, in Europe or in Japan, 350 kilometer per hour, your connection to internet is 100 megabit. That's what the technology 4G can support nowadays. But you require enough resources. Okay, at least you need 100 megahertz of bandwidth to provide that type of speeds. But when you move further to the next level in 5G, you can see that it comes beyond smartphone, beyond the connectivity. You are looking into not only they capable of having like autonomous car. It's possible because of the low latency that it provide, and also the manufacturing, smart manufacturing, digital healthcare, and all those things. So these are the things that we want to see. We want to see what will be the advantage or the thing that it can provide within that areas. Okay, I think with that we move to the C, and then we can see whether 5G is evolution or revolution. We know that 2G, 3G to 4G are all, we can say there is a evolution. It improve further the speed or data rate to be able to connect the higher speed. But when it comes to 5G, whether it's evolution and revolution or can be both. That's why the question here we can see when we're looking into 4G that I mentioned just now, the IMT Advanced is the technical in international telecommunication, ITU, that meet the 4G requirement where you set that to be 1 gigabit. This is for low mobility. Okay, so when you move from 4G to 5G, you are looking into enhance the mobile broadband. It can go up to 10 gigabit, even maximum to 20 gigabit. So the 5G, we can say just like a wireless fiber. Fiber can carry a speed of highest data rate 10, 20 gigabit, but with 5G technology, if you have that, it can also meet the same requirement that what fiber have. That's why sometimes we call it as a air fiber or the wireless fiber. This is one aspect on the extend further the broadband. But 5G not only that, because of this requirement of low latency, 1 millisecond, which is can have new application, new verticals can come in. For example, you can have digital healthcare, remote surgery possible, autonomous car is possible because the response is much better than human being. That's why we can have all autonomous. Doctor can be somewhere else, patient can be different place that it can perform like it is in the same location. And also the Internet of Things, because that's why we're looking into all things are in connected, like smart city, for example. Everything is smart inside there, where there are a lot of devices, a lot of sensors that we need millions of devices that 5G can support. That's why in the vision set by the ITU, there is IMT Advanced to meet the 4G, the requirement for 4G is this three pillar, where I can show here from this diagram. Okay, you can see this. One thing is enhanced mobile broadband, meaning that it is 10 times much faster than 4G, which means like 10K, 10 gigabit, 20 gigabit, just like a wireless fiber. But not only that, by reducing the latency, because in 4G, latency already have between 10 to 14 milliseconds. That's why we can do voice over IP. That's why VoLTE is possible. 2G, 3G cannot because the latency is very high, around 80 or to 100 milliseconds. So you have to use circuit switch to communicate. But with 4G, we can use voice over IP. That's why VoLTE is can be used there, right? But if you reduce further the latency that this in the 5G, you can do a what we call 4K, 8K. It's possible. You can do remote consultation. Doctor can be somewhere else. Patient can be different place. That as if they are in France of that. You can have an augmented reality or the AR, VR. When you wear the Google, this that if you use 4G, you can get headache because the delay, because it can your brain can detect the delay. But with 5G, with 1 millisecond, it's just like a real time. That is a possible in that. And then you can see industry automation in the factory, where we have robots. All most of the car now made by a robot and all those things. And those robot has to be coordinated and has to be connected. But currently they are use cables. But with 5G, we can put the with 5G over there, you can replace those cable with the 5G connectivity. Then you can have much better. You can also remotely monitor and remotely control. And also the mission critical application. For example, you are talking about remote surgery, where basically patient is different place. There is no specialist over there, but they're very critical that this operation need to be done. And with 5G connection between the 2 points, as if doctor are doing the at the same location, and this is possible. Self-driving car, you can see that when we drive the car, our response time is about 10 to 40 milliseconds. If I'm talking to someone in front of me, basically the latency that it will be is the 10 to 40 milliseconds. That's why our ear can respond. That's why we can have voltage in the 4G. But with 5G, the latency reduced further to 1 millisecond, meaning that better than human response. That's why when you're driving the car, for example, you are controlling, that is our response. You apply brake and so on. But with 5G, with 1 millisecond connected to the infra 5G network, then you can have 1 millisecond much better than human response. So that is the second pillar that 5G have. And then the third one, of course, we are looking into the message machine type communication, meaning that when you have a smart city, everything are connected. It will be million of devices will be there, and then that where it also integrate all the standard like you see now IoT. They have LoRa, they have 6.4 unlicensed band, and also in 4G they have NB-IoT. But in 5G, they are integrating all this into one standard, will become massive, then where it can support 1 million of devices per kilometer square. Okay, so with that, we can see, and all this application and all this mobile radio, you need to have a spectrum. That's why we can see here, the spectrum from mobile broadband, it can cover, you can see on the slide, where we have 900, 850, 900, 1800, 2.1, 2.3, 2.6. All these bands are used by 2G, 3G, and 4G. And what I mentioned earlier that 2.1 currently be used by 3G and some part of the 900 megahertz, where it cannot be replaced with 4G, then you get better quality. Beside the existing 4G spectrum they already have on 2.6 and so on. And then the coverage basically depend on the frequency. The higher frequency you go, the smaller will be the coverage, meaning that you need to have more base station. You're comparing 900 and 1800, the same area to get the same service, you need to have twice more number of base station if you use 900 than if you use you have 2.1 or 2 gigahertz compared to the 900 megahertz. Okay, so that is the thing. But when you move to 3G, 5G, we are looking into new spectrum. They are talking about lower band, mid band, and higher band. So in the lower band is a 700 megahertz, and the mid band is to 3.5, and even the higher band in the millimeter wave, you're looking into 26, 28 gigahertz. These are the spectrum, and the band is in Malaysia, for example, are given to a single wholesale network, where we have this digital national Berhad to operate those spectrum for the 5G. But 2G, 3G, 4G, you can see that the spectrum are given to many service provider, and they to roll out. For example, you have CDMU, Celcom Digi Maxis U Mobile. Also, you have Unify Mobile and YTL to provide that, right? So this is how the spectrum work. And then if you're looking into the specific 5G, that's why I'm saying just now, they support lower band where coverage can be much better than 900, especially in the rural area, and also in the urban area. The lower band is good because it can penetrate into the building much better. If you are outside, maybe if you use higher band, it's more difficult for the signal to penetrate inside there. But you also have mid band. It's a very important band, 3.5, where this is can provide the capacity and also the coverage most of the band. Then we have the higher band called millimeter wave. This is very high capacity, but the coverage may be around 200, 300 meters only. Okay, so those are the spectrum that you can see now. As I am referring, some country they opened it for many telco, but in Malaysia we only have one single wholesale network providing that, where other telco in the 5G they are talking about retails from that infra that been provided by the wholesale networks. Okay, and then I want to go to see. So what is the difference between 4G and 5G? What are the capabilities? You know already, 4G in terms of broadband is good enough if you get enough resources, enough spectrum, right? That's why in the Janela program, we extend further in the second phase of the Janela to get 100% 4G coverage, right? But now we are introducing 5G. So what is the capability of 5G? What are the things that 5G cannot do that 4G can do? So here we can make the difference. There are 8 differences that happen between 4G and 5G. The first thing, as I described just now, in 4G, it can support around 1 gigabit speed broadband if you have enough resources of 100 megahertz. But with 5G, it can go up to 20 gigabit, just like a wireless fiber. That's why it's called EMBB, enhance further the mobile broadband, right? Like fiber or Unify, you are using the fiber to your home. But with 5G, you don't have to use fiber. You can use a radio frequency to connect between the towers to your home, similar to what fiber can do. Second thing, you can see the age of the throughput. If you're talking about the cell, maybe if you are close to the cell, you get better signal strength. I mean, the throughput higher. But you move further, the throughput drop. But with 5G, you can maintain it as 100 megabit at the cell edge. This is what the expression of the Janela. We are looking into 100 megahertz megabit per second within the whole coverage that can support. And the third one is the efficiency. That's why if you are talking about utilizing the spectrum, if you use the same spectrum amount of the same bandwidth with 4G, then if you use 5G, you have 5G is 3 times more efficient, more efficient in utilizing the spectrum usage. And mobility. For example, just now I explained about the fast train, 350 kilometer per hour. It can have to be connected to the internet of 100 megabit for the 4G. But in 5G, it can go up to 500 kilometer per hour. Okay. Another thing is that very important things that will create new verticals, possible critical mission is the latency, where from 10 millisecond that 4G have, it reduced further to 1 millisecond. Okay, so this is made possible autonomous car. It's also made possible the digital what you call remote surgery, for example, application. You have better connection density per kilometer square. Now it can support more devices per kilometer square, and the network efficiency also much better. Maybe you're talking about 100 times better, and the area capacity within a given area, how many megabit it can support. The quality, you're talking about the quality that it can bring to that effects. Okay, so if you can take an example here, I'm talking about if comparing, even if we just compare 4G, LTE Advanced is it produce about 1 gigabit at low mobility just now, but 5G can go up to 20 gigabit. So that's the difference. And I think to reflect that, I'm trying to explain in terms of mobile networks. If you can see here, in any mobile network, they will consist of radio access network, they will consist of the backhaul, and also the core network. So radio access network we can see here is where we are connecting to the tower close to us, where we are communicating using the spectrum, using the radio channel. And To bring that towers to the core network, you need to have a backhaul. So the backhaul can be using microwave. That's why you can see a lot above the buildings or the towers that you can see there is some microwave link over there. You see, can see the parabola there. That being connected is connecting to the radio access to the core network, or relay it to the core network. Or we need to, you can use fiber. Fiber is more capacity it can carry. I think for 5G, really, we must have a fiber to be connected to the tower. And then we're talking about the core networks, where this is the important component also in the mobile network, where this core is all your database or information. If you can see, these are also connected to the internet, and it also connected to the towers through the backhaul. Okay, so these are the thing that, and what I try to share here is that what are the technology changes happening when you move from 4G to 5G, in terms of the architecture itself. And then we can see here, two things happen. First thing, we are looking into new antenna. So in 5G, they have a new antenna. To antenna there in 4G, for example, you have only omni. When you have a towers there, you cover the whole area, or sectorized. And most of people are connected to that. But in 5G, because they implement beam forming and beam steering, where we can have massive MIMO, multiple input, multiple output, more than one antenna, then we can possible to have beam forming where the beam can be focused to the user, and also the beam can be moved when the user moving, just like a spotlight. So it happens like this. When you are moving, the beam will follow you. They scared that what beamforming capability that they have in the 5G, and so on. You can see every beam connected to different user. So that is a thing. Okay, that's one thing. What we will see, that is the happening in 5G that 4G don't have. Second thing, we are looking into network slicing. You know, in the radio access network to the core network, they are connected by physical fiber or using microwave. And basically, when you move to 5G, you can have a network slicing. We can have a specific performance for specific needs. For example, you can slice it. That's why they are applying virtualization. You have physical fiber, but within the physical fiber, you can slice it virtually to depend on the what are the requirement required. For example, if you have the mobile phone, or you can have the autonomous car or other thing, they can be sliced according to the requirement, where this cannot be done in 4G, because 4G we just have the whole fiber or whole microwave will be connected between the radio access and the core network. Okay, and important here to understand the capacity. That's why the 4G can have more capacity, 10 to 20 times more in terms of speed, and also in terms of capacity it can provide. Because capacity, according to the Shannon law, there are three things that you can increase the capacity within the resources. You know that spectrum is very scarce resources, only limited. But how you want you to, like, it's just like a land. If you have land, how you do land? You can have multi-story building that you can have more density within the same land. Okay, so what you can do here, one thing is that we can have multiple antenna. That's why MIMO is important. In 4G, they already have MIMO. 4 by 4, 8 by 8. But in 5G, they are talking about massive MIMO. That's why one of the things here is the more antenna, just like if you have more pipes, more people can share. That is the thing. One thing. That's one way to increase. Second thing is that you need to have more resources, bandwidth. That's why you can looking into the bandwidth. That's why you are talking about the wider the bandwidth. Why 4G can support 1 gigabit? Because they have the required bandwidth of 100 megahertz. But most of the telco that we license, or the regulator given the frequency, is just 10 to 20 megahertz. So they can, it's not enough. But the technology itself can support. For example, you have 100 megahertz of bandwidth available to one telco. You can go up to 1 gigabit. This is, it depends on the capacity of the spectrum available, the bandwidth available. Okay, just like a pipe, what you call, the bigger the pipe, the more capacity it can carry. And the third one is signal to noise ratio. Meaning that if you are close to the base station, you get a good quality. maybe you're talking about full bar. Okay, you move away, maybe your bar reduced to 3, 2, and 1. But that also will affect the capacity. Okay, but you can see like a pipe having the, it move further, like having a rusty and so on. Okay, and then with this we want to understand how 5G can overcome this. Why we can maintain 100 megabit within the cell coverage, within the cell, in the general phase, final phase, phase 2 aspiration by introducing 5G. Okay, so that is the thing that that what is the advantage that, and then you can see, for example, massive MIMO that been used in the 5G. So massive MIMO is rising the technology that enhance the basic MIMO capacity. 4G have basic MIMO, four antenna at the base station. But 5G, we keep talking about 16T, 16R, even go up to 64T, 64R. This possible for you to do a beamforming. Okay, you have multi-beam. You can see here, every user have different beam and so on. And this is very key important technology in 5G that can support where they applying massive MIMO by having the, for example, 64T, 64R, when you can have different user have different beam, just like a spotlight. We can see here. So next we can see here, for example, here beamforming versus omni. If you are talking of omnidirectional or satellites, you are looking into the one base station. If you have a water, you pour the water, it will spread out. So what you are receiving only small portion of what being transmitted from the base station. But with 5G, since we have more element, you can focus the what you call the signal toward the user, then you can optimize it, meaning that you don't require the amount of energy required, only a small amount, just enough for you to get the quality from that. This is the beam forming. It happened, and also beam steering, meaning that it will follow the user. So I think from there we can see example here. This is 4G, where when you have a satellite antenna, for example, from the cell, you are talking about everybody is connecting to the same source. I mean the same coverage, yeah. And then and comparing to 5G, we're talking about each beam is focusing to different user. So which means you optimize the beam. The further you go, the beam will increase. Like what you see here, for example, in T-Mobile, for example, there is a where the user being used, and they are focusing the red ray to the different user being used. And the concept is here. You can see when you move the beam steering, then you will follow the user. But when you change your location further away from the base station, you will increase the signal to noise ratio. That means you maintain your signal to noise ratio, meaning that you can have better quality, better capacity in terms of that. This is the technology that been provided by 5G. That features that 4G not. Maybe I will show you a video. I don't know the internet connection is on smooth or not, but just to demonstrate examples of the beam forming and beam steering that been done back in 2 years by Ericsson and also in Korea. Okay, you can see here, for example. So the car is moving and it will be connected to the 5G uh, base station where they have multi-beam. They have my massive MIMO within that. Inside there, they have multiple at 6040, 64R that can do a beam forming. And you can see that the beam is following the car and is changed over to the other car. This is the concept that what it can do in the 5G, where we have beam forming being applied. Okay. So I think with that, maybe we are looking further here. So if you're looking here, you see that from the base station, 5G base station, we have MIMO, we call massive MIMO. We see that every user will be connected to different beam. And the same beam using by one user can be reused again in the different direction by other users. That will also increase the capacity that you have. Okay, so we can see that the data stream are targeted to each UE and do not interfere to each other. Okay, and these are the things, these are the technology that 5G have in terms of the antenna. Okay, and then also if you can see here, for example, when you have a high-rise building, normally you use omni or satellite antenna, maybe a higher levels of the building cannot be covered. But if you can put it into a verticals, then you can also cover the other areas as you can see in the diagram. So it increase the signal to noise ratio, increase the capacity, meaning that it also save energy because you are transmitting to the user enough energy. You are like you have in the room, you have a lamp. That lamp when you on, we can see it will cover the whole room. But what you require from that, maybe just to get enough for you to read. That's why what the beamforming and beam steering doing in the 5G network. Okay. So now there is one important things that changes happening between 4G to 5G is the massive MIMO beamforming. We improve further. Second is talking about network slicing. I'm mentioning just now that connection between the radio access to the core network, they'll go through fiber. But with 4G, we can use fiber or you can use microwave. But 5G maybe we must I think the requirement is to have fiber be connected to the towers because you need to have ultra reliable low latency. Ultra reliable mean it has to be 99.999% reliable, 59, because ultra reliable, you imagine if there is a something wrong on the backhaul side, what happened to the access where you're doing the remote surgery and all those things. That's why fiber, because we use microwave, sometimes microwave not so reliable because especially in our country where the rain attenuation, if for example if you see even the UC Astro in 12 gigahertz KU band, when the rain happened we can see we lost the picture, so that cannot be. Even you can get a good coverage within from the cell, but there is no connectivity to the core networks. Okay, so really fiber is a requirement that you need to be connected to that. That's why one of the aspiration in the Jendela program is to fix broadband where you're using fiber to all the premises. From currently the targeting is 7 million premises to be connected, but I think the aspiration to have 9 million fixed broadband connected, and that is will be requirement for that thing. So I think if you're looking into the network slicing, we can slice it for different application. For example, the benefit of the slicing is that, for example, you can give the different slice for automotive, for digital healthcare, for manufacturing, because they have different requirement. Whereas in 4G, you are talking about the same cables or same fiber connected to the same thing. You can customize the slice. You can optimize for the needs, and this will increase the capability. Like you see in the diagram, the old approach one fits size fits all. Like the bicycle, you see this person comparing to 5G approach where it meet to the different requirement, have different things. So this all this been done virtually. Software virtualization and softwareization been introduced into the 5G that make it possible. Okay, so there is a one thing there. And finally, we can see in the network slicing where we can see that it can slice according for EMBB, for your ultra reliable low latency, and from message machine type communication. There are different requirements, so you can slice it virtually between the radio access network and the core network. Okay, so what the technology that origin this virtualization slicing can be 100% managed by the operators, like a single wholesale network, for example, or the third party or retailers like other service provider that will be using that network. Okay, and then you can see that we can also fit to the requirement, the different bandwidth, the latency and power consumption and so on. So okay, so in general we can see that the things that difference between 4G and 5G. Okay, even we need 4G. Sorry, there is a mistake there. 4G versus 5G. We can see first thing faster data rate, where we have 1 gigabit 4G, 10 gigabit 5G. That is the thing that we have already I demonstrated showing just now. Second is the higher device density that it can support what we call this is called message machine type communication, where you can have 1 million devices per kilometer square. And the third one is the latency. Latency reducing from 10 milliseconds in 4G to 1 millisecond, where we can see new application is possible. And lower energy, meaning that you can have the beam forming, where you can only focus to the user, you can optimize the beam, comparing 4G and the 5G, and also the efficiency, network slicing and efficiency. Okay, so I think I will demonstrate here about the 1 millisecond latency. If we can see here, uh, so this is the concept only. When we're talking about 5G latency, this can happen in the concept. Maybe I play the video here. Okay, you can see that they have this 1 millisecond latency. You don't have to worry about the car will be colliding with the people and so on. So because the car already have sensors, there is one concept that happen that if 1 millisecond possible, this is what 5G can provide. Okay, with 1 millisecond latency. Okay, second one we can see that if you are looking into this robot, you see the wire inside the robot. The robot can move very precisely along the wire without touching. But if we are a human being, we are taking the probe and try to move along the wire, for sure it will touch the wire. So that is our response of 10 milliseconds. Comparing with a 5G is 1 millisecond. That's why remote surgery is possible, right? That's why you need to be ultra reliable. 99.999% reliable. Otherwise, it's not meet the ITU requirement or 5G requirement that require that. Okay. Okay. I think next we will see what is the benefit of the 5G. You can see here the benefit of 5G here. Take an example, the use cases where the 5G can produce in terms of EMBB, in terms of ultra reliable low latency, and also in terms of massive machine type communication. For example, you have this building. With this building, the close to the building is the what we call, you have the towers there, where these towers are connected to the fiber. And this from the tower to the building, you can have, say, if you want to have the unified or broadband, fixed broadband, you normally we have a fiber to be connected from the towers to the building. But with 5G, is 5G available there? You can use that 5G has the link, wireless link, that is what called air fiber to the building. Okay, and if for example, this building you have a clinic where you can do the scanning or ultrasound or any information, but the specialist is not there. But within the 4G, we can make a comparison. Sorry, you can make a comparison between 4G and 5G. If 5G, that means it's just like real time, just like so the doctors in the other location, they can view the scan of the knee, can give advice and so on. Okay, otherwise you need to be there, like a cable connected. Okay, so another example here is the we can have this what you call hologram, for example, the autonomous car happen there, and also the smart city where all the things are connected. These are the three pillars that you can see here. For example, here, when you see further, for example, you have fixed wireless access. Normally, we can see here that the towers there is connected by the by fiber, and from the towers to the premises, they are all by fiber or unified. You can see to the house, but with 5G, you can see that you can replace those by 5G signals where you have beamforming. And for example, you have another location, especially in the suburban area where they have a scattered houses. If you want to bring the fiber to those locations, will very costly. The physical fiber, you have to make the hole, make the pole, and so on. But with 5G, where we can have connected to that through wireless to fix, but it's a fix to replace cable, and that can reduce the cost. But because the 100 meter or 200 meter, the cost is the same when you are using the wireless system comparing to the wired system. So we sometimes, if you require a point there, you can see like this. Maybe there will be a lot of cable or fiber be connected to that. Okay. Another thing is that when you are talking about one location, at any one time there will be 100,000 people in the stadium, for example. For sure, 5G can 4G cannot be used. You can see that not enough capacity to provide this capacity. Just like happened recently, I think on last Thursday, you can see that in the National Stadium Bukit Jalil, when this Johor JDT and Terengganu, you can see people, if the amount of people inside there like this, for sure your 4G won't work. I mean, become capacity is not enough. But it can have 5G can capable to meet that. Another example I give you is the remote, like hologram. Like I'm giving the talk here remotely, but if with hologram, as if you can see me like a physical connection there. I can show you this example. So this is some demonstration be done using the hologram. I am not there. I am somewhere else, but I'm talking to the people in front there as if I am there. Okay, so this is possible. So in the education side, for example, okay, with 5G, and okay, in the next one is we are looking into manufacturing. You're looking into all robots. All robots are all connected, but they are connected by cables. With 5G, you can replace all the cables where robot can move around like if they are connected by cables. Okay, I think one more thing I want to share here is that the related to remote surgery, where we have, for example, the doctor in the Kuala Lumpur and the patient is in Sabah, for example, where since if both location are connected by 5G, then we can have this remote surgery being done. But this is lithroscopy. I just show you the video, you can hear it.
Seperti dulu, di mana kita kena bedah. Kerana sekarang kita tak bedah, kita hanya tepuk lubang yang kecil saja. Dalam kes Puan Syahidah, kita nampak ada hanya 3 tepukan lubang. Satu lagi itu namanya laparoskopi. Satu lagi cara ialah cara robotik, di mana melalui tepukan yang sama, kita masukkan alat robotik dan melakukan operation dengan cara robotik juga. So actually operation dia lebih kurang sama, cuma kita menggunakan robot supaya pembedahan tu lebih teliti dan lebih accurate lah.
Seperti apa yang kita sedang bayangkan sekarang ni.
So kalau nampak saya tak ada di tepi sakit tapi hanya robot di sana sebenarnya saya tengah duduk di konsol bagaikan macam konsol video game
Okey.
So itulah boleh nampak
macam main game pula.
Actually saya tengah buat pembedahan and saya tengah tengok video secara langsung lah melalui robot ni.
Tapi kontrolnya di situlah seperti bermain game.
Saya yang buat control tu.
Okey, kejap.
So I think you can see that this is possible if you have the 5G where it's 1 millisecond. So what happened here is that you can see that the doctor is using the joystick controlling the robot. But the doctor is just next door. They are connected by wired cable, because cable wired, they are very reliable, and we can say that and also the low latency, very low latency, because doctor is just in the next room. But with 5G, just now we can show that the doctor can be in Kuala Lumpur, the patient can be in Sabah, for example, and then it can do the similar thing because the connection within the two terminals is very reliable and so on. So this is possible. Where we're talking about. This is just an example. And also, I think 2 years back, there are some demonstration about the 5G, where you do a remote consultation in Langkawi and Alostar. This is where demonstration been done, where doctors, specialist is in the Alostar, ENT, and the patient is in Langkawi, but he can give advice through that because of the remote consultation. Possible with 4K, 8K, as if the doctor is there. You can see very clearly what is happening, and so on. And then also this another examples where they are talking about the connected ambulance, where the ambulance are equipped with all the facilities and connection with 5G between the ambulance and the hospital. The patient on the way to hospital, the information, for example, for example, you have this what you call the scanning and all the ultrasound can be sent to the hospital. When you reach the emergency, then everything's already there, and then the doctor can do a quick action come to that. So this is just an example where the digital healthcare can provide that possibility. Okay, other verticals that I want to show here is on construction. You can see here, the construction here. For example, this in Japan. The person controlling the excavator is somewhere else. But in the site, there is no no people controlling that. This is the demonstration done. And when I visited, what you call the, at that time, I have tried this, where I remotely can control the excavator from the other sites. Okay, so just another example. Okay, and then other things that I mentioned here is application that possible is the vehicle, V2X, where you're talking about vehicle to pedestrian, vehicle to vehicle, a vehicle to infra. When you're looking into vehicle, within the vehicle itself, if you buy a car now, there are a lot of sensors already. It's already to assist the driver. For example, if you are out of the lane, they'll give a warning. You have camera in front and in the back and so on. And if you are following the car, for example, if the car slow, you will be also slowing automatically. You won't collide. But if you are connecting to the infra with 5G, much better response. That's why what is designing. The car will have all those facilities. Okay, and then the car being connected, others car also connected to the same infra, and then they can be coordinated. This is what the feature that 5G in terms of automotive. Okay, and you can see here, for example, the sensors it have from different cars and so on. Okay, so this is one thing. And another thing that I want to share here on construction. Maybe I open the mic. Maybe you can listen to the what happened in China. It's already happened in China.
With 5G technology, the mining industry has evolved tremendously more than previous centuries combined. They were in Tianye Cement Company in central China's Henan province. We're here to see how this traditional industry has been transformed in 5G era.
现在这个地方是无人远程操作台，在这里可以操控1公里以外的那个挖掘机。这个操纵杆往右边是右边旋转，往左边是左边旋转。这个摄像头都是360度的，全方位都能看见。通过5G，这个精准度也提高了，安全性也提高了。现在我是在这边远程操控这个运输车辆来运行轨迹，然后我这边控制启动，它会自动运行。如果说这边出现什么状况，我这边都可以监控到。以前的话，一个车就是需要一个司机来去开它，对吧？但是现在的话，我一个人可以控制15辆车，就是15辆车可以正常运行。我这边只需要负责它一个启动或者停止。
You think I invented this, but wait a minute. Take a closer look. You'll find there's no driver in the cab. The large bandwidth and reduced time lag of 5G technology can greatly improve the ability of precise and selective mining. In 5G era, remote mining is expected to see great development. It's the way towards the future.
Okay, so that just one examples application of the 5G in the construction or in the mining side. It's already happened in China. They are demonstrating on that. And next one, basically, we are looking into this is some field trial being done in Japan. We get that the one on the remote consultation and so on. I think it's stuck there. Okay, so this are what happening in Japan. Back 2 years ago, we tried on the 5G. Okay, I just show because I think the internet connection is not good. Jadi, I just
Tidak nampak. Video Prof tidak ada di sini.
Tak nampak.
Tak ada. Video tidak ada. Ya, ni masih lagi construction punya video.
Ini.
Ada video.
Oh, I see. Maybe I reshare again. Can? Yes. Maybe something wrong with the connection. So I think betul berapa? Can you hear me?
Boleh saya dengar tapi masih jerking. Prof ni ada ni.
Oh, jerking. Maybe I skip this. Maybe I try to unshare. Maybe because of the video part, because it's not suitable to transmit because of the internet condition.
Jika ada sebarang soalan, bolehlah tuliskan di ruang chat. 1-2 soalan mungkin kita boleh beri kepada Prof Tharek nanti untuk ni.
Okay. So kalau dia ada soalan tu can write dekat chat tu, nanti mungkin saya tak boleh, nanti Dr. Muzaffar boleh baca lah soalan-soalan tu, mungkin saya boleh ni.
Baik.
Right.
Sila boleh tulis 1-2 soalan untuk kita berikan kepada Prof untuk jawab sebentar lagi. Thank you Josh, nanti kita bacakan soalan you ni. Mungkin kita boleh mohon satu lagi soalan yang boleh dicantikkan di ruang chat box sambil kita menunggu ni. Prof will start isi.
Okay, boleh
Boleh. Now okay. Massive machine.
Okay. Massive machine type communication. Okay, jadi kalau kita boleh sambung balik Ada sikit lagi slide nak habiskan dan lepas tu kita pergi pada Q&A lah.
Sila Prof.
Ya, yang kita lihat tadi, pertama saya dah ucap minta maaf lah ada berlaku sikit technical problem tadi di sebelah sini. But anyway, we have seen already that the 5G have three pillars. That means we have EMBB. So what the capability of 5G can do in terms of like a wireless fiber, and also the remote consultation, and then you can see that the ultra reliable low latency. This is the second one that I'm showing just now, where we can have the remote surgery in construction, remote construction, and all those things lah, manufacturing. And the third pillar that they have in the 5G is a massive machine type communication. And you imagine that we have millions of devices per kilometer square in this area where all the things are connected. That's why we are talking about earlier I'm mentioning that now IoT have all this using the LoRa 6.4 in unlicensed band. They are using also what we call MB-IoT in 4G, but in 5G are looking into all standardized together and it become massive. And in this what you see, you'll be or have a smart street, smart parking, smart entertainment, smart communities, and so on. That this will make very massive things that been connected to the internet. And again, how 5G can support, you're looking into remote site monitoring, the M2M consumer intelligent diagnosis and so on lah. So those are the things. So these are the three pillars that I mentioned that 5G can support. And all these are the sensors that required lah, okay, where to be sent and so on. Okay, in terms of the implementation, we can see here, usually you can see that the 4G and 5G, they can work together. In the first stage, they call it as the non-standalone, meaning that, you know, in any base station, for example, there are signaling, they call data control plane, which is a signaling channel, and also the data plane, this is the user channel. So when you implement for example, 4G, if the 4G already available 100% in the Peninsula, Sabah and Sarawak, for example, in our Janela program, then we can have 5G in anywhere where it can use the control plane of the 4G, and then you are using the data plane or the user plane from the 5G. That this one can take advantage of the EMBB, enhanced mobile broadband, right? But this is what we call standalone, where 4G and 5G can work together. But if you want to apply like a low latency, ultra reliable and so on, you need to have a standalone, where in the standalone, we can see here, they are separate network. But the phone that we have can be connected to both, right? So when we have 5G phone, of course, we will be attached to the 5G. When you have no coverage of 5G, you will be fall back to the 4G and so on. So this is how, and we need to have a separate core network for 5G in order to implement what we call the critical mission, that means ultra reliable, low latency as examples. Okay, for example, if you have this throughout Malaysia, Sabah, Sarawak, all the coverage of 4G is available there, so you can implement 5G, for example, in a given location. Because some application of 5G for enterprise not required everywhere. So, for example, you are talking about manufacturing site, you're talking about agriculture where they have massive IoT over there. Even you can see that even in the city, we have a smart city where sensors are there. not everywhere sensor required, but you already that location. And for example, you want to do the remote surgery that I showed just now. There we can have a hospital in Kuala Lumpur and hospital in Sabah or Sarawak. Then remotely we can do as if the doctor is there. A remote consultation is possible. Okay, so this is one thing that is possible with the 5G application. From horizontal, we can say that just talking about connectivity, where that 4G can be done by broadband and so on, but to verticals, that means you have new industry coming, digital healthcare, manufacturing, and so on. So I want to, again, this is a video, I don't know, I hope the video can, just to talk about the 5Gs, technology, just to give understanding.
5G is the next generation of wireless communication networks. They say 5G will be different, but how? 5G will impact in so many areas of our everyday lives and the world we live in. There are 5 key aims. 1. Minimum end-to-end latency. 2. Dramatic improvement of quality of experience with immersive and ubiquitous connectivity. 3. More efficient utilization of resources. 4. Reducing network capex and opex by flattening the network architecture. 5. Supporting versatile applications via flexible software-defined networks. With 5G in place, we can expect to see groundbreaking developments for key applications in the world around us. For example, the Internet of Things will become more connected, making lives easier. Intervehicular communication will mean safer travel. Entertainment will have more depth. Your social network will become fully integrated. And healthcare monitoring services will be pervasive and integrated. There are a diverse set of technologies that will drive 5G, including integrated information-centric networking and content caching. Dense network, meaning 5G shouldn't break, so no more data dropout. Utilization of network context. And utilization of user context for a more personalized experience. In contrast with previous networks, 5G benefits from memory-full and intelligent network management technologies, allowing for faster operations with minimum signaling overhead. Overall, users will have a better experience, and networks will become more efficient and profitable. Join us.
Okay, so I think you can see the video just explaining what is 5G all about, that summarize what I am explaining just now. Maybe the next one, we can see what is the economic impact of the 5G. For example, when we are implementing deployment in Malaysia, so we can see that deployment of 5G will serve as economic and innovation driver for Malaysia. As you can see that the capability of 5G just now, what it can, what it call serve or innovate, serve the economic improvement. The 5G connectivity also important for the country development. For example, we can see just now, we have automotive, digital healthcare, agriculture, manufacturing, and so on. And also 5G set foundation for future technology and business growth in terms of data speed, in terms of low latency and massive network capacity. And also the mobile service provider can introduce an innovative application where you can from there. So also I think if you understand now, Malaysia is embarking on the Digital Malaysia, that is my digital initiative, where industry also including manufacturing can benefit from the 5G, where we are enabled to have economic positively, right? So here we can see that what the outcome it can be in terms of 5G implementation. One, in terms of the economy. Second, on the social and also the environment. We cover all the verticals. For example, agriculture, digital healthcare, oil and gas, retail, smart transportation, banking, education, manufacturing, and also smart city. So at least by understanding what the features, the capability of 5G can have, and then it can what you call take advantage or benefit from what they can be used for. So the general, as we know that is a very important initiative by the government, to improve further, but I don't want to go in a bit more detail here. But anyway, as we know that the aspiration of the Daniela is to get a digital infrastructure and coverage map. Now, if you, for example, if you go to the jandela.my, you can get your quality, or you can see what is your response or your coverage at that location, and it doesn't meet the quality of experience, the one you can make a complaint or to the MCMC. And also they are talking about improvement plan for coverage and quality. That's why I think they are sunsetting 3G as mentioned earlier, replacing with 4G, we has more quality, and also expanding the coverage. Now they are talking about phase 1,661 new 4G base station being rolled out to cover the underserved area, and all these things to meet 96.9% of the coverage in the populated area at the speed of 96.9%, the requirement. Also, the optimizing of resources. That's why we close 3G. Why 3G been sunset? Because we optimize the usage of the spectrum by replacing 4G with 3G. We get better quality. That's why we are looking into gigabit, what you call fixed broadband to the premises, where I think that 5G can support that as well by having the fixed wireless access like a wireless fiber. And we can see that the especially to get 100 megabit everywhere, where 5G can do that, where we can have consistent. And one of the other important also in that is the 4G coverage is 100%, where when we have 4G coverage everywhere, when you want to implement 5G is quite easy. Okay, so I think so the rollout timeline for Malaysia, for example, here, we already have the 5G coverage. I think first phase by end of last year in Putrajaya, Cyberjaya, and Kuala Lumpur. There are about more than 500 sites already there. Okay, and then the government is planning to have 40% coverage in populated by end of 2022, meaning that by end of this year they are expecting to have other states. Now they are moving to Johor, Penang recently, and other states, I think including Sabah and Sarawak as well in some location. But the aspiration is one to have by 2024, there should be an 80% coverage of 5G in the populated area. So when we say populated area, meaning that when there is a people about 20, more than 20 people per kilometer square, that we define as a populated area by the DOSOM, Digital of the Statistic Malaysia. This is the aspiration. We can see that by 2024, there will be 80% 5G coverage. Okay, and I think the rollout of 5G also, I think recently the Minister Tan Sri Anwar Musa have mentioned that the government to ensure 5G rollout remain planned as planned. That means they are targeting. The issue now that they have in those locations that have the 5G coverage are all, I think at the moment, the YTL, yes, provide the service. Coming soon will be TM. And I think the other telco also agreed to be part like Celcom and DG. And but I think recently there is some, I think that U-Mobile and what you call Maxis is looking back, and then because government have opened 70% stake in the DMB for this service provider to be part of the okay. So that is a thing that happening, but I think for sure that 5G rollout will happen throughout there, where because we are waiting for 2024 to have 80% 5G coverage, where we can benefit from what I have explained just now. Okay, so I think in conclusion, we can say that we understand about the evolution of mobile communication from 1G, 2G, 3G, 4G, and move to 5G. And earlier on, mobile communication more focusing on the voice. And then as you move from analog to digital, we can capable to have text messages can be sent. But when you move further to broadband, where we can have internet at least 2 megabit in 3G, then they're possible to have then improve further from 3G to 4G in terms of the evolution of the mobile broadband. But when we come to the next generation in 5G and things, it will be both evolution and also revolution. That we can see just now what are the things that 4G can 4G cannot do that 5G can do, then we become verticals, okay? And we can already also can be aware that the differences between 4G and 5G, especially in terms of ultra reliable, low latency, where the new things that digital healthcare is possible, critical mission, and so on. And the benefit we can see that about the 5G is very huge, where we can spur the economy in terms of this in the pair of 5G. All right. So I think with that, maybe I would like to end my talk today. I'm sorry about something that happened just now where I could continuously, maybe because of the video, I have some issue there. Okay, I hope you get some idea what is the benefits of 5G can do, and what are the what you call that features that it have, that it can help the human being. Just take an example. For example, if you are traveling from, say, Kuala Lumpur to Penang, for example, you're using the car. That is just like 4G, where you have many people, you can reach there. But 5G is just like you are taking the aeroplane, the flight, where you can put more people and faster and more secure. That's the thing that happen, right? So I think Dr. Muzaffar and all the participant, the lecturers and also the postgraduate student. I hope you learn something. Then I stop here. Thank you very much for your attention.
Thank you very much, Prof. Tharek. So kita ada satu, we have one question in chat box. So saya bacakanlah, Prof.
Ya, boleh.
So I have one question. Is the 5G backbone deployed physically or virtually separated from the 4G backbone? The fiber deployment, optical VPNs, and L2, L3 network components. For example, the fiber deployment, optical VPN, and L2, L3. What impact will 5G have on backhaul network as it is still connected to the same fiber incoming with 4G? Dalam chatbot ada, Prof.
Oh, okay. Okay, I think as we see that in the mobile networks, we have three components. Important one, there's the radio access. We have a towers where we are connected to that, and that towers has to be connected to the core networks. And every telco they have their own core networks. Okay, for example, I just start off with when you are talking about sharing, where they are talking about having their own core networks connected to the radio access, but they have to be connected. In 5G, really, I think better to use is a requirement for the fiber to be connected. But when you're looking to 4G, because, for example, where 4G can also be connected to the core network, you are using microwave or you're using the fiber. This is the physical fiber, meaning that only one requirement. You cannot do any visualization. You cannot slice it. But I think in the fiber, they have many cores. For example, some of the core carry the 4G, where it's a dedicated portion, but you have some of the slice of the core within the core that we can use. You can slice it. For example, you can have different requirement for different. So that is physically the same core, but you can visualize it separately when you implement 5G connected to that. So that is possible, because but I really need that all the towers that connected to 5G really require fiber to be connected. And I think other question I've forgotten. Saya tak dapat baca chatbot, tak nampak kat sini.
Satu lagi, what impact will 5G have on backhaul network as it is still connected to the same fiber incoming with 4G?
Okay, I think okay, maybe like I mentioned just now, if we have, because the core of the fiber can carry quite a lot, where you sometimes in the core in the fiber you have dark fiber. Dark fiber means the core is not being used, and those dark fiber can be utilized with 5G, where you can have a single, even they have physical fiber connected between the core to the radio access, but visually you can slice it, which cannot be done in 4G. Maybe you can have a new fiber or use existing fiber. If there is a additional spare fiber not being used, then you can utilize it for 5G. But for 5G, when you're utilizing for 5G, you can do a slicing, meaning for that. But 4G, you cannot do that. 4G has to be dedicated. So either you need to have new fiber or you can use the existing fiber which have a spare core or spare fiber is within that network. Okay.
Okay, thank you. Thank you untuk jawapan tu Prof. Ya, Josh, okey lah ya, Prof. Josh, dengan jawapan Prof tadi kan. Right. Oh, give me one last question. Okay, ada satu Prof. Can you say about cost to an individual home user of 5G facility in the future?
Can you say again?
Cost to an individual home user of 5G facility in the future lah.
I see.
Cost ni lah.
Okay. You mean the cost to the user, yeah?
Yes.
You can see that because of the capacity it can carry, because of the volume, because of the efficiency you have, the cost per gigabit should be less than what 4G can provide. That's why I think before when we talking about, because we have a lot of capacity over there, but with the large capacity, the cost per gigabyte will be lower compared to the 4G, for example. So this is what the government aspiration to get the lower broadband cost to the end user. Okay, I think that's it. Alright.
Terima kasih. Yeah, thank you very much Prof. I think cukuplah masa kita dah 11, lebih kurang 11.40 dah. So thank you very much. First and foremost, I would like to express my appreciation to Prof Tharek for his available talk in this session lah. Thank you very much, Prof. And then give a big props to Prof. So my deepest gratitude goes to all who attended this talk and helped to make it a successful event. Finally, my deepest thanks to of course, to the Secretariat for their priceless contribution and also for running a smooth event. Thank you very much, Prof. Till we meet again with another series of talk in the future, inshallah.
Yeah. Inshallah, we'll see again in the future. Okay, thanks all for the.
Bye.
Bye.